Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. In today's video we are going to discuss about sight distance in highway engineering, types and calculations. The safe and efficient operation of vehicles on the road depends very much on the visibility of the road ahead of the driver. Thus the geometric design of the road should be done such that any obstruction on the road length could be visible to the driver from some distance ahead. This distance is said to be the sight distance. The actual distance that is observed along the road surface which is visible for a driver from a specified height above the carriageway is called as the sight distance at a point. This distance will let the driver see all the stationary and the moving objects in front of the vehicle. What is sight distance in highway engineering? Sight distance is a length of road surface which a driver can see with an acceptable level of clarity. It plays an important role in geometric highway design because it establishes an acceptable design speed, based on a driver's ability to visually identify and stop for a particular, unforeseen roadway hazard or pass a slower vehicle without being in conflict with opposing traffic. IRC, Indian Roads Congress, has standardized the definition by assuming the eye level of driver as 1.2 m above the road surface and height of obstruction 0.15 m from the road surface. Types of sight distance. 3 sight distances situations are considered for design. Stopping sight distance, SSD, or the absolute minimum sight distance. Overtaking sight distance, OSD. Intermediate sight distance, ISD, equals 2 times SSD. Other types of sight distance are safe sight distance to enter intersection, headlight sight distance, stopping sight distance, non-passing sight distance. It is the minimum distance open to the vision of the driver to intended to stop the vehicle to avoid collision with an obstruction, moving or stationary, which is present on the carriageway. It is also termed as non-passing sight distance or non-overtaking sight distance. Safe stopping sight distance is an important factor in traffic engineering. It is the distance a vehicle travels from the point at which a situation is first perceived to the time the deceleration is complete. In highway design, we consider sight distance equal to the safe stopping sight distance. There is a term called safe stopping distance and is one of the important measures in traffic engineering. It is the distance a vehicle travels from the point at which a situation is first perceived to the time the deceleration is complete. Drivers must have adequate time if they are to suddenly respond to a situation. Thus in highway design, sight distance at least equal to the safe stopping distance should be provided. The stopping sight distance is the sum of lag distance and the braking distance. Lag distance is the distance the vehicle traveled during the reaction time t and is given by Vt, where v is the velocity in MSEC2. Braking distance is the distance traveled by the vehicle during braking operation. For a level road, this is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. If F is the maximum frictional force developed and the braking distance is L, then work done against friction in stopping the vehicle is FL equals F times L. Where is the total weight of the vehicle? The kinetic energy at the design speed is 1/2 times m times 2 equals 1/2 times 2 F times L equals times 2 times L equals times F. Therefore, the SSD equals lag distance plus braking distance, and given by SSD equals V times T plus V2/2 times G times F, where V is the design speed in meters second 2. T is the reaction time in seconds, G is the acceleration due to gravity, and F is the coefficient of friction. The coefficient of friction F is given below for various design speed. The coefficient of friction F values as per IRC. Design speed in kmph. Longitudinal friction, F, 20 to 30, 0.440, 0.3850, 0.3760, 0.3665, 0.3680, 0.35100, 0.35. If the road possesses an ascending gradient in an amount equal to and n%, to the braking action the component factor of gravity will be added. This will decrease the braking distance. This component of gravity is acting along the direction of the braking force, which is given by W sin W tan equals Wn/100. After equating the kinetic energy and the work done, we get L equals V2/2 times G, F plus N/100. We can also derive the braking distance for a descending gradient which is performed similarly, and we get SSD equals V times T plus V2/2 times G, F plus or minus 0.01 N. Practically, the sight distance designed should follow the following rules. For one-way traffic with single-lane road or for two-way traffic on multiple-lane roads, the minimum stopping distance is equal to the stopping sight distance. This is because there is no chance of collision of vehicles moving in two opposite directions. so it helps to enable the driver to stop the vehicle from colliding with any obstacles. Therefore, SSD equals SD. For two-way traffic movements in a single lane, the minimum stopping distance is twice the stopping distance as because there is every chance of colliding the vehicles with opposing ones. Therefore, SSD equals 2 times SD. If reaction time is 2.5 seconds and coefficient of friction is 0.42 at 20 kmph to 0.28 at 120 kmph, then the increase in SSD on downgrades is as follows. Speed in kmph. Increase per 1% grade 120. Six 100. 4.580. 360. 1.5. Stopping sight distance depends upon the following factors. A feature of the road, i.e. the horizontal alignment, vertical alignment, traffic conditions, and position of obstructions. Height of driver's eye above the road surface. Height of the object above the road surface. Overtaking sight distance, passing sight distance. It is the minimum distance open to the vision of the driver intended to overtake a slow-moving vehicle safely without causing collision with the opposite vehicle is known as OSD. The overtaking sight distance is the minimum distance open to the vision of the driver of a vehicle intending to overtake the slow vehicle ahead safely against the traffic in the opposite direction. The overtaking sight distance or passing sight distance is measured along the center line of the road over which a driver with his eye level 1.2 m above the road surface can see the top of an object 1.2 m above the road surface. Factors affecting overtaking sight distance. The main factors that affect the OSD are spacing between the vehicles, speed of the vehicles, the gradient of the road, the acceleration rate of the overtaking vehicle, the velocities of the vehicle which is overtaken, and that coming in the opposite direction, the driver skill, the reaction of the driver. Many overtaking models are made for the overtaking process, but the data obtained from actual observations and from these models are not very reliable. For the following model we have the following assumptions. The overtaken slow-moving vehicle travels at uniform speed. The overtaking vehicle reduces its speed and follows the slow-moving vehicle as it prepares for overtaking. The overtaking vehicle requires the reaction time to perceive the situation, react and start acceleration. Overtaking is accomplished under a delayed start and early return, and travel during actual overtaking operation are a formally accelerated travel. Analysis of overtaking sight distance. The process of overtaking is shown in the figure, which consists of three parts. The distance traveled by overtaking vehicle during reaction time, t, i.e., d1. The distance traveled by the overtaking vehicle during the actual overtaking operation in time, t, i.e., d2. The distance traveled by oncoming opposing vehicle during the overtaking operation in time, t, i.e., d3. Therefore, OSD equals d1 plus d2 plus d3. Vehicle A traveling at design speed has to overtake vehicle B on two-way traffic lane when third vehicle comes from opposite direction. D1 equals distance traveled by overtaking vehicle A during the reaction time TSEC at position of driver A from A1 to A2. D2 equals distance traveled by vehicle A from position A2 to A3 during the actual overtaken operation within time t. D3 equals distance traveled by vehicle C from position C1 to C2 during overtaking operation of vehicle A. Calculation of D1 equals it is a distance traveled by the overtaking vehicle during reaction time, t seconds, of the driver. D1 equals v. T calculation of D2 equals it is distance traveled by the overtaking vehicle during overtaking time, t seconds. Initial speed equals v. Acceleration equals a time equals seconds. Therefore D2 equals v. T plus 0.5 times a times t2. From the above fig, D2 equals b plus 2s, so b plus 2s equals v. T plus 0.5 times a times t2, v. T plus 2s equals v. T plus 0.5 times a times t2, b equals speed of overtaken vehicle equals v. T. According to IRC, s is given as s equals 0.7 v. Plus 6. Therefore D2 equals v. T plus 2s. Calculation of D3. D3 equals distance traveled by the opposite vehicle during seconds. D3 equals v times t. Finally O.S.D equals v. T and v. T plus 2s and vt. Note, v equals v 4.5 ms. If the road is single-side traffic lane, then there is no vehicle C that comes into opposite direction. Thus D3 is neglected. Then total overtaking sight distance equals D1 plus D2. Safe overtaking sight distance equals 5 times total overtaking distance calculated when there is no restriction of land. Or safe overtaking sight distance equals 3 times total overtaking sight distance when there is restriction of land. Overtaking zones. Overtaking zones are those areas provided when overtaking sight distance cannot be provided throughout the highway length. These zones include traffic signs which inform the driver about the start or the end of the overtaking zone kept at the distance of overtaking sight distance. These zones are used for overtaking operations and are marked with wide roads. Minimum length of overtaking zone equals 3 times OSD. Desirable length of overtaking zone equals 5 times OSD. Sight distance at intersections. At intersections where two or more roads meet, visibility should be provided for the drivers approaching the intersection from either sides. They should be able to perceive a hazard and stop the vehicle if required. Stopping sight distance for each road can be computed from the design speed. The sight distance should be provided such that the drivers on either side should be able to see each other. This is illustrated in the figure. Design of sight distance at intersections may be used on 3 possible conditions. Enabling approaching vehicle to change the speed. Enabling approaching vehicle to stop. Enabling stopped vehicle to cross a main road. Headlight sight distance. The distance that is available for the driver during the night travel is called as the headlight sight distance. At night the drive is facilitated by the illumination of the headlights. The PIEV theory was proposed to provide a detailed account of drivers' reaction time. PIEV theory splits the reaction time of driver into 4 components. Perception, time required to perceive an object or situation. Function of eyes, ears. Intellection, time required for understanding the situation. Function of brain. Emotion, based on our emotions at the time, fear, anger, etc., we reach the decision whether we want to stop or not. Function of brain. Volition, once the decision of stopping has been finalized, time required for moving the foot from the gas to the brake pedal. Function of hands or legs. Total reaction time equals perception time plus intellection time plus emotion time plus volition time. As per IRC standard, reaction time is 2.5 seconds. Thank you for watching. Please subscribe, like, share and do not forget to press bell icon.